Yes, hi Deepak.
Hi, good evening.
Good evening, Deepak. Good evening.
Good evening, sir.
So, all well?
Yeah, I'm good. I'm good.
Yesterday,
Hmm.
backhauling we have covered, correct? Till backhauling, I think we.
Calling.
Hmm.
Today failover.
Yes, fail over. I was checking. PPT we have covered. So, what I can do, I'm sharing. Today, please let me know a little bit. I'm confused. Where was we? Here or here? I think here we was. We were here.
We did that synchronization. Correct.
Hmm.
So here you told you will later tell me in detail. Just you gave me a basic idea of synchronization.
Hmm.
How we are supported, like for example, right now with GPS, satellite, then linking to all global network. So that is one example you told. So you told later we will cover this part, and after this you told you asked me about failover.
Now here, 2G, 3G and 4G. LTE is the 4G. There is a word LTE, long-term evolution. This is 4G.
4G. No.
So you see here, this is E1. This is E1 plus FE both. Any one you can choose. And 4G is Ethernet. So as per the OSI rule, this is layer 1.
Layer 1.
This is layer 2.
Layer 2.
Or this could be layer 2 or layer 3, anyone.
Anyone. Okay.
So that means first we need to protect physical infra.
Yes.
Protection failover. So anything goes wrong with physical infra, my switching should happen. I should switch over on another path, correct?
Yeah.
So protection for layer 1 is different. Protection for layer 2 is different. Layer 2 and layer 3 protection is different. So for understanding protection in every layer, we need to know what protocols are running on which layer.
Correct.
Because every protocol has different processing and timing scenario.
Yes.
First step is understanding the layers as per OS. This is the thumb rule. Second stage, segregation of network. So here is the end user. This is end user.
Yes.
So end user, here to here, we say UNI section or client side, common word. UNI or client side. Same way, after this, end user. So this is my UNI section. User network interface or client side. Now, as per this network, here to here, section 1, section 2, or end-to-end section. Correct? So this section is called NNI or line side, network to network integration. Network to network integration. So for the time being, you remove this one. Let it be like 3 sections only. Network to network and UNI to UNI. So we have total how many sections? 3.
Yeah.
So let us draw a line. Section 1. Section 2.
Yeah.
Section 3. Breakage can happen in any section.
Yes.
This is NNI. This is UNI, user side. NNI means network side, UNI means user side. So breakage can happen anywhere, so we require failover.
Yes.
So after classification of this, we need OSI layers segregation. What service? Then you came to know if it is a 2G, this is my layer 1.
Yeah.
This is my layer 1.
Correct.
It could be my layer 1, layer 2, or layer 3. It could be layer 1, layer 2, layer 3. So any permutation combination may happen.
On the NN you're saying, or on the UNI? Your voice is yeah.
It is
I
okay.
think it's better. Yeah, it is okay.
Listen, this is my UNI portion. This is my UNI portion.
Yes. That I understood. This is NNI.
L1, L2, L3 can work in any layer. It could be L1, it could be L2,
or it could be L3.
it could be L3. So any permutation combination I can carry.
Okay.
We
On
need
the
to
UN,
check.
on the UNI you're saying. Okay. Okay.
Nowadays L0 as well.
L0 as well.
So, but let us talk about OSI only right now.
Okay. Okay.
So any combination, L1 can carry over L2, L1 can carry over L1, L1 can carry over L3. Means once I came from here to here, I can go with anyone.
Okay.
I can go with L1 on L1.
So one
over L2.
So one has an issue, then immediately it is taking over the other one, whichever is available. Okay.
Yes.
Let's say layer one has one issue on UNI. There is no need that it has to go only via L1. It can be a primary, but still if it is a failover, it has a capacity to take it through L2 or L3 also.
No, please understand. At a time, L1 can enter either on L1, either on L2, either on L3. So switchover will happen in its the same nature.
Okay.
Please understand the hidden line over here. You forget about right now failover. First understand, L1 can carry
enter any three.
So once you choose any one, failover will work for that only.
Okay.
You got my point?
So I have a question here. Okay. So when you're saying from if you choose L1, okay, and L1 can choose only L1, L2, L3, but if it will that be configured in such a way so that the load balancer will not the limitation issues or any kind of capacity issue?
First of all, on the transport side, transport network, you know, now you clear what is transport network?
Yes.
So NNI to NNI, there is no concept of load balancer.
Okay. Okay.
Load balancer only works for a VPN networks where MPLS or VPN networks are running.
Oh, okay.
Because let me give you an example. Infosys, correct? They are software companies, data center companies, but they are not ISP. No telecom service providers. So they all their application running on the leased bandwidth.
Yes.
So they buy the leased bandwidth for application and forming a VPN.
Yeah.
If my geo network is failed, then I should have another leased bandwidth from Airtel.
Yes.
So this switch over, if I deployed layer 2 or layer 3 network only at my location, then it is required.
Okay. Okay. Understood.
If I deployed leased bandwidth from Bharti and Airtel and Jio on my individual multiplexer, that is layer 1, load balancer, because L1 has this functionality to control. So no extra equipment we deploy. You got this line?
Understood.
All depends what OSI layer is passing in the during transit on what layers that you need to find out. So here we were in discussion, UNI to NNI passing is not automatically, it's you planning team who will do this decision configuration. It is nothing like that automatically layer 1 will switch to layer 2 or layer 3. Integration is not happening like that way. It will not work. It's you who need to do this physical connectivity. If I need to connect my E1, I will connect to the E1 only. So physical connectivity will not change from L1 to L2, E1 to Ethernet, because this is physical patching. How physical patching will be changed? Only signal is getting changed automatically. Physical patchings are not getting changed. So at the time of configuration or integration, you will define, I will carry my L1 UNI to the NNI on L1 or L2 or L3. So once the configuration done, they can change the path failover, but that is within layer 3 only. If I configure layer 3, not from layer 3 to layer 2. You got this line? No?
Yeah, I'm trying to.
Okay, again,
No. I understood, sir. I'm just trying to connect the dots. Okay. No, it is clear. Now it is actually clear.
So let us assume, draw 3 sections. If I am carrying layer 1 at a UNI, this is my UNI, this is my NNI.
NNI, yeah. UNI.
If I carry my L1 over L1, I hope L1, I'm using word L1, you clear. What does it mean by L1?
Yes, yes.
I don't need to repeat.
No.
L1. L1. This is called my native services. Native means I don't need to change my formatting, encapsulation. It's the same language, transit in the same language, reaching at the same language or encapsulation.
Yeah.
It will work, no issue. Now, passing via L1. Sorry, passing only L1. Passing L1 to L2 and finally reaching L1.
Yeah.
Technically possible, no issue.
Yes.
Passing L1, passing on L3 and receiving L1. Technically, yes, possible. Protocols are different in every case.
Yeah.
So here, transition from L1 to L2. Sorry,
Yes.
L1 to L1.
L1 to L1. Yes.
So protocols, nothing, no protocol conversion is required. So this is called native service.
Native service.
Yes. If passing L1 to L2, this is called CES service. CES. Have you heard CES?
No.
Circuit emulation services. Emulation services. These are the protocols that do the conversion. Look, CES is an interpreter. Once is two people speaks different language, then do we require one interpreter, common interpreter?
Yeah.
The same way, CES is the interpreter. L1 is English, L2 is Japanese. So we require one interpreter. So CES is interpreter.
Okay.
Same way, L1 is passing on L3. Here we require pseudo wires. PW3. Again, this is interpreter. So we do this configuration. This is nothing like that automatically it will happen. At the time of configuration, physical patching we are doing, then doing configuration for these protocols. So for you, and right now at this stage, this is not necessary to know how to do the configuration, but understand architecture, this is the important.
Fundamentals.
Yes, how signals moving.
Okay.
So there is nothing like once there is a fiber cut here at this point. If there is a fiber cut at this point, it doesn't mean that it will switch over from here to here or here. Yes, it will find out from here another part that should be also a layer 2 only. You got this slide? If there is a fiber cut, then I will switch over, but again I will find out my layer 2 only, layer 2 type only. If there is fiber cut in layer 1, if it is layer 1, then I will not switch from here to here. I will find out layer 1 path only.
Okay.
You got this line?
Yeah. So it is like within the native level, we are trying to find out the fiber. I mean, if there is any fiber cut.
By own, same nature.
Okay. Same nature.
Yes.
Yeah.
Switch over will happen, but that is within the same nature.
Same nature. Switch over.
So here, now you see, PW is a pseudo wire. Just I shared with you what is pseudo wire. Once layer 1 convert to layer 3, this is pseudo wire. So you got it. Now coming to the layer 1. Layer 1 switch over is supported by SDH. Already we discussed. By OTN.
L1. Yeah, L1.
Yes, by OTN. And switch over time is 50 millisecond recovery.
15 millisecond recovery, yes.
It's guaranteed every time. Every time, guaranteed. Guarantee. You can give guarantee to anybody. Yes, written, black and white. Industry says, scientist says, proven. Layer 1. Now, come on layer 2 and layer 3. For example, this one, VPN. VPN is IP?
Yeah.
VPN, virtual private network based on IP?
Yes.
This do the switching. What is the timing? switching time less than 200 millisecond. Switching time for IP Ethernet less than 200 millisecond.
Yes.
If anybody configures their application 100 millisecond, so do they face the disruption every time at the time of switching from one operator to another?
Yes.
So what is the solution? Ask their application to raise more than 200 millisecond.
More than 200 milliseconds.
Yes, 210, 202, 203. I'm responsible. My configuration is responsible. If I crossed 200 millisecond and still you face disruption, yes, then my problem it is.
So the switching has to be less than 200 milliseconds only.
Yes, till then it is acceptable. Industry
Acceptable.
Yes.
Yeah.
Industry can't say no. Miss any IT guys. Generally, IT guys they are talking. Okay, no, not accepted. Even let me share with you. Industry layer 1 is the global ITUT standard 50 millisecond. Even I'll start losing switching. You are losing some frame. You are not able to 40 millisecond or 30 millisecond. People are talking, but this statement is not acceptable at all. Reason being, this is technology. And every switching lost some frame, but that frame industry says it is acceptable under the limit. So anybody raise the question or raise the concern and payment on quality level, then away this statement we are rejecting. No, this is not acceptable. So we suggest them, okay, you get some information, come back. Don't hold my quality and my payment. You accept this because this is industry standard, global standard. So yes, we need to deal with them like that way. And this 200 millisecond also not guaranteed every time. Sometimes it may increase. Depends on the router processing. If your router is fully loaded, overloaded, then switching may raise up more than 200 milliseconds.
Okay. Correct me if I'm wrong. So when we had initially when we had this discussion on L1, 50 millisecond is as per the industry standard, and for L2, I remember you telling me 50 million to 500 million second, which is not a standard, but it depends on the company's portfolio or
correct configurational. Configuration
portfolio. I mean configuration requirement. So we may go according to that. But tell me, see now I have let's say I have got like 200. I go with 200 millisecond. Okay, I say this is the way I am following for my VPN. Okay, so because here if I do a switching and the opposite, like the customer says, okay, I cannot accept this 200 millisecond because my current project runs only on 100 millisecond. So at during this such situation, how do we actually tackle it?
In this case, we come with some white paper that is from IEEE. There is again like ITUT controlling only L1, L2, L3 controlled by IEEE and IETF global standard.
Yeah, I am aware of L2 IEEE.
Yeah. So in their protocol white paper, there is a called white paper. So in their white paper, you can get it. You can tell them, okay, this is the configuration. We can't support like that way. Plus, these are the protocols convergence. Maximum what we can do, we can check it out our network convergence time. That is not paper calculation. That is as per the actual in the ground within the network loading. You load your network with a traffic generator as a sample. You check it out the switch over time, you calculate on the system, testers are coming, maximum side, and you let customer know. If still he consists, you straight away raise your hand. Day one, you raise your hand. Rather than, okay, after 10 day, 5 day, or after 1 month, 6 months, bashing will come. You regularly, clearly tell them in a written black and white, no issue, because this is technology limitation.
Okay, so I got your point now. So when you're saying initially have this discussion so that you don't want to get into any kind of issues. Let's say I am just to accept the new business. Let's say to transition a new business. I'm agreeing with the customer, and customer is also saying it's okay. I mean, if you can manage it, we are okay. And my limit is like 100 milliseconds, and I know you have a 200 millisecond. Like you said, if I put an exception also there, and what if tomorrow there is a failover, okay, and we did not meet the expectation? How do we handle such situation?
Correct. What is happening? Sales guy generally going there, they commit anything. Correct.
Yes. Correct. True.
So what is happening? Let me share with you one more technical example this way.
Hope. I mean, I'm actually asking the right question.
Yes.
Okay.
So what is happening? There is L1 bandwidth. L1 bandwidth generally, if you sell out, then 10% bandwidths are overhead. Means customer can't use it. whatever bandwidth they will buy, they use only 90%.
Okay.
In L1. So for example,
Okay.
if I order 100 Mbps, I will be able to use max to max 90 MB only, 91, 92, like that way. Average 90% only.
That is your resource allocation. What you're
No. I'm coming on this. If I allow L2 or L2 bandwidth, so I will be able to use almost 99%. Both are Ethernet here. So customer, once their IT in charge, they will sign it or accept it. They raise the bar. Okay, I'm hardly getting 90%. How I can pay for 100%? Here they will pay.
No.
Yes, here they will pay. Layer 2 they will pay because they are getting 99%, almost 100.
Oh, so, here. Sorry.
Yes, they will pay.
No,
but here they will not accept. They will accept it with a comment.
They will, correct.
With one observation, I am getting only 90%, 10% bandwidth. I am not getting. You got my point? Understood, sir. Understood. IT guys generally raise up this question.
Yes.
It happens. Regularly happens.
Happens, yeah. I mean, I have gone through such situation where they have given so many goalies. Okay. That's why I was like little confused.
So why it happens? Because this is technology. Technology says whatever traffic I will flow, this traffic will be in the ratio of 90% traffic and 10% for management. This is technology. It's whatever the traffic you will flow, I will just it that is under 90%. On top of this, I will add my 10% management data.
Oh, okay.
And this is technology, ITUT. Yes. That's why layer 1 is the more robust in transport, not accepted layer 2 or layer 3 as a transport. Layer 1 accepted as a transport because they have ensured with a 10% of overhead bytes. Overhead data means management bytes. That's why L1 is still running, and it will be running like anything even again 10 to 20 years. But still it will be in a running position because they are giving guarantee, and this 50 millisecond guarantee due to this only. This 50 millisecond, yes.
So does this have any reserve allocations also, or there is no reserve allocation?
Reserve? Yes. So whatever bandwidth you have created here to here, you will not able to allocate to customer.
Okay. But so that itself is a reserve. Okay.
So you will sell 100%.
I will sell 100%, correct. But the actual part is totally different. Yeah. 90, 10.
So I am putting this 10% to ensure your reliability. So ultimately, my resource. But yes, as a sales guy, sometimes sales guy forget to mention this 100 L1 bandwidth. If they mention L1 bandwidth, then no dispute in discussion. We can explain it. But due to some reason, generally sales guy forget about mentioning this line because they are not technical person. They want only sell. So, okay, 100, you take it 100.
Yeah.
So what is happening now? Disputes created here.
Yes.
Only 100. They have not mentioned layer 1 or layer 2 bandwidth. So dispute arrives here. So in this case, then we are offering to the customer, okay, you want layer 1? No issue, I will give you 100%. But layer 2 has its own pros and cons. Layer 1 has its own pros and cons. So you decide what you want. Then he will ask, what is the pros and cons? The cons in layer 2 is it is not giving 150 millisecond recovery guarantee. So now IT guys is okay. For me, my failover is more important than 10% bandwidth. So no issue, you take 100% payment. So now he will give it to you. Got this point?
Yeah, understood.
So layer 1 failover, layer 2 failover, layer 3 failover. Everywhere failover will happen, but within a same layer they will switch. Failover, nothing like that. Layer 1 to layer 2, it will be switching. Correct?
Yeah.
Even let me share one more example. Here you have given layer 1 bandwidth, correct? So switching will happen less than millisecond. Any cut if happen between here?
Yeah.
Here, one server is there. You connected with one cable, you connected with another cable. FE port, this is layer 2. 2 ports you connected. because it might possible your one port or one cable is faulty.
Yeah.
So you can connect your server with two Cat5.
Backup port. Backup
Yeah,
port.
backup port. So this is layer 1 and layer 2.
Yeah.
So what will happen? Any fiber cut will happen at this place. This recovery will happen within 50 milliseconds. Correct?
Yeah.
So no issue. Customer is happy. Now, customer knows 50 millisecond recovery I am taking because this is layer 1. Because they are asking, I want layer 1 bandwidth, not layer 2 in transition.
Understood.
So he is ensured less than 50 millisecond. He is happy. But let us assume no switching happen
Within the same speed.
yeah, at this place. Happen. So this is called NNI switching because network side. And this is my UNI.
Yeah.
This L2 is my UNI. So this switching L2, this is my layer 2, not layer 1. Okay? So layer 2 says this one.
Less than 200 milliseconds or
Maybe or may not be. And the 50.
may not be. May not be. Understood.
So anything goes wrong, service disruption will be there. For
Yes.
few seconds.
Yeah, it is there, but it's a loss.
They will observe packet loss on interface.
No, it's a packet loss.
Will happen. But whosoever the person sitting at this place, they will say, okay, every time after switching, I'm facing the problem. My session is break. There is session breakage. They starts blaming service provider.
Yes.
They will call everybody. I'm facing telephone calls dropping over here.
Yes.
So concern, what is the problem here? How to tackle this problem?
First, we need to see what is the switching speed.
No, I need to check switching speed. You know already it should be anywhere in between under 200 milliseconds.
But we need to check the blaming the ISP provider. But we need to see, is it going in the same bandwidth or not? If the bandwidth is not meeting up, definitely there is a problem.
No, bandwidth is okay, everything is okay. Switching problem is taking too much time over here. Too much time means your application is sensing the shifting, switching, they are sensing.
Correct.
You can say this is the technology limitations. We can't do anything.
That is, see that. Okay, I was trying to say the same thing in a different way. Like, okay. I mean, this is the limitation. This is the limitation I'm saying.
So application, if application has some timer application in application, some timer option, you raise it to 300 millisecond. But generally calls, data is fine. But in a call, telephone calls and all, they will not wait. They will drop. Like a data, internet data, they are tolerant for this. But voice calls are not tolerant for this. They will be dropped because path is disconnected. Let me one live example.
When you say, okay, the voice will get disconnected, okay. So when we are actually voice will get connected. It's not only one. Let's say idea has got idea has got less than 200 milliseconds or 50 milliseconds as an option. I mean, is the limitation. Sorry, not option. Is a limitation. And Airtel has got less than 300 milliseconds and less than 50 milliseconds. So here we definitely see a difference of 100 milliseconds. Correct. So Airtel calls are getting dropped on Idea network due to this bandwidth issue, due to this switching issue. Okay, so I know that, I mean, when I do the analysis, I will get to know, okay, this is the reason it is getting dropped. Okay, but we cannot force the carrier, or we cannot force them to say that, okay, you have to upgrade it to 100 milli. I mean, another plus 100 milliseconds to reach to get those calls. Okay, because that is not there in my what do you say? That is I cannot do that. So this is the limitation I have. So on such cases, okay, how do we actually accept it? Because the idea will say, okay, this is my limit. I'm not doing anything. Airtel will say, I mean, this is only this is what we have. So we will not do any changes. You want to accept, or you don't want to accept, just leave it. So there are chances of losing some, what do you say? I mean, forget about the business. So yeah. So how do we actually get over this?
No, again, please repeat last line. I lost it.
No. How do we get over such situation? I'm asking.
Okay. Listen, first, like you said, idea for 200 and Voda for 300, correct? All this 200, 300 happening on a layer 2. For example, let us assume I have one server, correct? Idea is going via this way, connected. I have another ring of Voda.
Okay.
And I have connected here.
Okay.
So first of all, you understand at which point switching is happening. So any fiber cut at this place, so switching is not happening over here.
It's not happening over here.
Switching is happening from here to here. So it will give you 50 millisecond if it is a layer 1 bandwidth.
Correct.
Same way, if I'm going this way, this is fine. If any fiber cut, it will switch on over here. So I will maintain 50 millisecond if this is L1 bandwidth.
L1 bandwidth, yes.
This is L1, this is L1.
L1, correct.
Now, due to any reason, this is disconnected. This cable is disconnected. Due to any reason, signal lost.
Correct.
Either complete blackout this infrastructure, or this port is faulty, this port is faulty, or this cable is faulty. So switch over will happen at this place.
Yes.
So it will take 200 milliseconds, less than
200 milliseconds.
Always 200. It may less than 50 milliseconds also, but not guaranteed.
Not guaranteed.
Who is controlling this device? Service provider is not controlling.
We are controlling.
Yes, we are means customer is controlling.
Customer is controlling, yeah.
So we can't place a call to the service provider because control point. Who is doing configuration over here? Who planned this type of scenario? Service provider not planned.
Service, no.
Yes. What will happen if my server is connected over here and this is not switching, but at the same place at this point switching here to here I am facing disruption, then service provider having problem. Not switching here, switching at this point I am facing disruption. Yes, service provider has problem. But again, if this is layer 2 bandwidth, no guarantee.
Okay.
Even service provider layer 3 it is no guarantee.
No guarantee. This. Okay.
Means it may see 250 millisecond it is written, both written.
Yes.
Sometimes it may switch. Depends on router processing length, fiber length, or how much kilometer, 1,000 kilometer traffic needs to travel. So all communication comes somewhere, bottleneck is there, bandwidth crunch is there. So all this combination happening on a VPN side.
So there is a limitation you're saying, like apart from, let's say, for my example, if I take, like Voda, if it is 300 millisecond also, still there is the opportunity for them to land, get the call there, but
no
there is an
guarantee.
exception. No guarantee, exception.
Yes.
So the policy based, we can say policy based.
Yes.
Understood, sir. Thank you.
But nowadays a new technology come into picture for giving the guarantee for layer 2 and layer 3.
Oh wow, okay.
They came. They not came means they have not developed L2 or L3 with guarantee. What the industry did, everyone was happy with L1.
Yeah.
Because everything is guaranteed.
Yes.
So what they did, they did some property, overhead property of 10% like that. What exactly, we don't need to go in that way. But they inherited OAM functionalities of layer 1, and between layer 2 and layer 3, they invented one, you must heard MPLS. But MPLS also not giving guarantee.
Okay.
Layer 2 and layer 3, correct? Layer 2 plus layer 3. In between, MPLS is running as per SI rule. Correct?
Correct.
And Layer 1 has transport OAM functionality,
Yeah.
operation, administration, and maintenance guarantee. So what they did,
OA.
OAM, operation,
OA.
administration, and maintenance. These are the overhead bytes, OH, overhead. Extra bytes 10% that we discussed already. 90% and 10%. Did you remember?
Yeah.
So what they did, they mixed these two functionalities there, and they come up. Who did this? Is IETF, international body. IEEE and IETF invented MPLS.
Okay.
And L1 is controlled by ITUT.
ITUT. Yes.
So what ITUT and IETF come together with a new technology, MPLS TP. That is called transport profile. Transport profile. MPLS TP. Transport profile. Till now you got it?
Yeah.
So MPLS TP came into picture with a terminology called tunnel. You know, once you enter into tunnel, there is no left and right. Correct?
Correct.
So tunnel means enter and out. No need to checking out any processing, adding
only entry and exit.
Correct. So this way we save our processing.
Yeah.
So that's why they came with picture. They try to control like a layer 1 OAM overhead, and they controlled, and they give less than 50 millisecond. So a standard defined by ITUT, that is called Y dot. If you will search, you will find out Y dot 171 is the ITUT standard for PLSTP OAM. So if you don't remember, no issue, but concern is industry came with layer 2 and layer 3 protocols. There was no guarantee for failover in MPLS less than 50 millisecond. So they came with new topology that is called MPLS TP, and that defined by ITUT, because ITUT controlled transport profiling only. So it is guaranteed 50 millisecond.
So these are all optic fiber, or sorry, these are all Ethernet service.
End of the day, everything on Ethernet.
Ethernet service. Understood. Does it even include in the optic also? No.
Yes. Look, if you connect, these are the encapsulation. Correct. So encapsulation is being processed inside of equipment. Once it outs from the port, what is this traffic is, carrier doesn't know. Fiber optics, let it be copper cable, doesn't matter. Let it be wireless, doesn't matter, because they are the carrier only. Like truck, whatever you can upload, they will carry. What is inside, they doesn't know. Even they doesn't bother about this. Carrier, this is the carrier.
Yeah.
Encapsulation is handling via transmitter and receiver only. That's it.
Understood.
So I hope you got failover and you will able to handle now.
Yes, sir. I'll do a little bit of reading also.
Plug and play. Basically, this is in a ring protection. It's displaying you in the ring protection. Ring, like failover. If it is in a ring position, then only. Otherwise, no switching will happen. See this one.
Only ring position. Oh, okay. Okay.
See, every section they are displaying what it is running.
L2 VPN, IMPL. Okay.
No guarantee here. No guarantee here. No guarantee. No guarantee. But yes, this is a TP in a L2, L3, MPLS TP guarantee.
Okay.
If it is a layer 1, then guarantee.
Yeah.
This one. Switch. Unified management. Layer 1, layer 2, layer 3 traffic. So you can correlate with this.
Yes.
We discuss. It could be layer 1. It could be layer 2.
Layer 2. It could be
layer 3. And this one could be, you can pass it via
NNI.
It may be 3 logical circuits are here, L1, L2, and L3.
L3, yeah.
Now it's your call where you want to pass it.
Mm-hmm.
Means user's call. You want to pass it here, you want to pass it here. You don't want to pass it on L2, then you pass it here on L1. The protocols will be changed in that case. You want to pass it here to here, pass it. But switching will happen within the same domain. L3 will switch on L3 only, L2 will switch on L2 only.
L2 only.
Yes. And this is a single connectivity. What else will happen if this is down? Then we can have another connection, 2 connections.
Yeah.
Let us assume this is L1. So 50 millisecond guaranteed.
Yeah.
But which point? Till which point? Not guaranteed end to end. Till this point only. Till this point only. What will happen between here to here? There is no guarantee. If anything goes wrong over here, there will be traffic disruption. This is less than 100, 200, 300. No guarantee. Means I can say I can insure 50, but I will not give you guarantee. This is
understood.
So whatever infrastructure we prepared, that we required connectivity on a NMS or OSS site with help of protocols. So these are the protocols what we discussed.
Understood.
Now out. So same, they are displaying where is protection per link, single link, or where to where link. So every transition you need to check it out. Every transition you need to check it out as per the OSI rules. As per that, your protocols will be applicable, and your failover, guaranteed or not guaranteed, as per that they will decide. So guarantee one thing, please memorize. Summarizing 3 things in a network world, telecom or IT. Only 3 protocols, technology giving guarantee. Otherwise, no else is giving guarantee for 50 millisecond. One is SDH. Another is OTN. And third one is MPLS TP.
MPLS.
Not MPLS, MPLS TP. Both are
the new one, what you told.
Yes. This is both layer 1. This is layer 2 and layer 3. But yes, layer 2 and layer 3 in association with layer 1 OAM. So all this should be on your fingertips. If anybody is running out of these 3, till the point it is guaranteed, after that, no guarantee. So these are the few connectivity failover consideration for the mobile core. Discuss later on what is this LTE, SAE and all. This is the connectivity and signal process. Generally have EPC, the packet core in mobility, is handling internet. If you're surfing internet from your cell phone, so this is EPC who is handling this. So this is the connectivity, the signal flow.
This is a signal flow.
Yeah, we will discuss again this portion while discussing this mobility.
Okay.
3G, 4G.
Yeah.
These are the before we will discuss 2G, then we will come on this.
Sure, sir.
This slide is important. Last, this is with clock protection. All.
This one.
This one.
Okay.
Yes, clock server. One is binded with one time stamping, that is clock server. This is GPS.
Okay.
The equipment has its own frequency clock internal. So they are not working on that. If you disconnect the GPS link, then start working on their own timing. So it creates the problem of synchronization. Like I sent one packet with one time stamp, there it may change. I don't want. All my equipment should run with a one time stamping. So I need to feed some external clock, and that external clock is generally a GPS, and that GPS is feeding the time stamping to all the active portion. So once they receive the signal, they stop taking internal time stamping. They take up internal once external clock failed. So this is happening automatically, but we need to feed external clock.
Okay. So that's a manual or do we automate that part?
Manual.
Manual.
At one point we feed, and further they propagated with packet. Like here we are feeding
Mm-hmm.
one or two, like a failover, same failover.
Same failover. Okay.
Yes, one or two or three, depends on the network infrastructure, geographical area.
Hmm.
I will not feed them. They will transmit it internally.
Okay. Okay.
But yes,
So at what level do we do the check? Is it a random check or how is it?
no, there is a clock planning, proper
Yeah,
simple.
yeah, that I understood. I mean,
Mhm,
like you said, I understood that part. So
mhm,
as we know, okay, that it is processing. If there is
mhm,
a failover happened, let's say, I mean, when you're saying
mhm,
internally it is happening. So let's say it is
mhm,
connected to some 8 different layers or 8 different
mhm,
elements.
mhm,
Okay, and one of the element it has got some there is some malfunction.
mhm.
And on such, how do we get to know that this particular area is affected?
Look, what is happening? Immediately they don't switch. How
Hmm.
to work? At the runtime, I am passing the packet, correct? Passing the
Yeah.
packet of time stamping.
Hmm.
Assume this is disconnected.
Okay.
So I will not immediately switch to my internal clock.
Okay.
What is my last best saved quality signal level? That I will remember for 4 to 6 hours.
Okay.
That is
Okay.
called holdover mode.
Mm-hmm.
Holdover.
Okay.
Almost max to max 24 hours. I will run from the best known quality level. After 24 hours, I will lost that value also and switch on
Mm-hmm.
to internal clock. Whatever clock it is set in my network, I will start my internal reference. So you start losing the packet. 1%, generally it is coming like that. On the interface, I'm losing 1% packet loss. And generally phone calls, there is a
Yeah.
silence for few seconds. Then again starting voice coming, start coming. Then again silence, some noise
Mm-hmm.
due to latency, because it is taking too much time to process the data, or not getting sync. I am little bit slow, other network is very much fast processing. So this is all our disruption, sync disruption will happen, and we start losing the percentage of packet, like 1%. Link will not down, but your quality level will be degraded. Let us assume from 100% to 99%. So this 1%, normal data is not going to impact, means normal user not going to impact, but any real time scenario.
Yeah.
For example, any TV streaming, you starts receiving some glitches, your voice,
Yeah. Yeah.
some noise, some silence, so that you will start like that. Some call drop.
Mm-hmm. Yeah. This happens on VoIP calls. We have experienced it.
Hmm.
There has been a dead voice or where
Hmm.
customer says like there was a dead call where we see I mean you are talking to the user and all of a sudden it's like at least for 30 seconds to 1 minute there is no voice at all. So yeah, such issues we have heard.
Correct.
They this is mainly told during that PBX is dead. Is that something we can relate?
You can relate, but PBX is not responsible for clocking and all. But yes, beyond, like from here,
Hmm.
told PBX will connect.
Hmm.
Some EPBX is there. That EPBX may be connected via nearby some here.
Nearby. Okay. Okay.
Yes.
Which is the nearest
Exchange,
what do you
command
exchange
office, central
command
office.
office. Mhm.
So any clock disruption will be there in this case,
Mhm.
this area. Call will not drop. Some percentage call loss will happen.
Call loss will happen. Mhm.
Call, even I'm not dropping any call, but some noise starts coming, some silence starts coming.
Mhm.
This will happen.
Dead calls, like a dead calls. Mhm.
Yes.
Mhm. Yeah, yeah. This we have experienced. I mean, during our service desk time, we have experienced a lot.
Mm.
But I mean, one of the reason which was told to us, as it is coming through cloud, I mean, it is like it is there could be some resiliency in other third
It may
party.
no, it may
happen.
possible. It may
It
possible. You don't know. Look, there are too many equipments are there. Which
correct.
any equipment starts malfunctioning and takes
Mm-hmm.
time, how you will come to know?
Yeah. Sometimes, I mean, those logs we cannot get in our own network. I mean, it will be
Hmm.
impossible for us to get that. Yeah, we
Yes, it
face that.
might possible. Even
And
everything is fine,
mm,
clocking and everything is the screen is visible.
yeah, you just have to blow it. Yeah, thank you.
Okay.
Thank you so much.
So even means no sync is disturbed, everything is fine, but you
Mm-hmm.
some security encapsulation to
Yeah.
to security end to end, some firewall over here, some firewall over here, and it is taking too much time due to misconfiguration.
Mm-hmm.
Then also your voice call may disrupt, may take more time, may take
Yes.
some voice drop, some errors.
Errors. Yes.
Yes. So
Because see,
VoIP.
we VoIP call, we used to take it via Avaya, and Avaya call, whatever gets logged in, we know. I mean, our screen is also shared, so we used to see that synchronization. Like when we used to tell sometime customer or clock, when the customer used to ask us like, is it your clock synchronization is as per your Avaya? And we used to give the timestamp, Avaya timestamp of our clock, and they sometimes they used to tell, okay, there is a nanosecond difference which we see on your machine, so we may have to relook, or we may have to re-image your machine, or so these some of the issues have occurred. I'm not sure to what extent telecom is actually supporting it. Is it the same thing or not? I just want to check it.
So concern is you need to check it out. What are the components involved? Somewhere you will get some clarity. Okay, I'm passing through this layer. Somewhere you get, if passing through some cloud, who is controlling that cloud? Who is sitting outside? They will not come to know.
Okay.
Mm.
Understood.
So who is sitting outside the cloud? They will not know where data is, from which path is following. But yes, who is controlling the data? That cloud. They must be able to know that. They will
See,
find.
what we do from here is we first thing we check with the network, and the network team connects with the ISP provider. So whichever the current ISP provider through which the call has dropped, we will see that, okay, let's say if Reliance is doing it, we go back to Reliance, we ask them, okay, was there any issue? Like we see a call drops happening or packet loss happening. Reliance, they come back saying, no, we don't find any issue here. So when we try to blame it to the customer, I mean, blame in the sense we try to tell the customer, okay, we got this. This is the timestamp, and this is what it is. And the next thing they ask, like, I mean, have you checked the machine? Is like the clock synchronization. So that's why yesterday I gave you that example, because we had this experience where they told Avaya is not configured. Okay. See, when Avaya is not configured properly, and where they asked us to do configuration, and we followed it. There also we have sometimes they say, okay, it is lagging because of by the time the call is coming from there to here, there might be a 2 to 3 seconds of delay, due to which the call landing is a problem. So those are some things. I don't know whether it is right or not, or whether can we
Right.
it's right. Okay,
This is right. Listen,
this is right.
for example, if you're passing any real-time application via L2 or L3. So for Ethernet, by nature, Ethernet is asynchronous.
Yeah.
What is asynchronous? It's buffer in nature, bursty in nature. What does it mean? Ethernet is bursty in nature, asynchronous in nature. What does it mean? Ethernet is bursty in nature, asynchronous.
Worst in nature. Okay, worst in
Yes.
nature.
And
So
asynchronous.
weakness or any kind of weak connectivity.
No.
Okay.
Every connection is perfectly fine. Ethernet by default is bursty and asynchronous. What does it mean? Means suddenly 1,000 packets came into at the gate. Suddenly nobody is there, and they're moving here and there. This is the nature of Ethernet. Broadcasting means like a mob. We can't control mob. So like a mob, it starts moving. And VoIP call on Ethernet?
Yeah.
RJ45 connector.
Yes.
So we are handling Ethernet at the last mile, last point.
Last point. Yes.
So do we need any external mechanism to control this? Mob should go in a line, in a queue.
Yes.
So here on a Ethernet, sync protocols came into picture. That is called 1588v2, defined by IEEE synchronization protocol. 1588v2 PTP, Precision Time Protocol, PTP 1588v2. This is name is protocol. See, here it is written. See, here to here, what they deployed.
1588v2.
Yes, this is PTP.
PTP.
Precision Time Protocol. Because here to here all Ethernet.
Yeah.
So by default, any let us assume new device that is coming by default 1588v2 enabled. Let us assume this is enabled 1588v2, 1588v2, 1588v2. Let us assume any older version running here who doesn't have 1588v2.
Correct.
And everybody having 1588v2. So once link, yes, there will be some impact. Yes, minor impact. What impact will be there?
Impact will be there. Yes. Yes.
So they start finding, okay, where is the problem? Then if you will, they will go for the configuration. Service provider will check, okay, my this route, it doesn't have 1588v2 enabled. Like you said, here I have 1588v2 functionality, but due to some misconfiguration, I disabled it.
Yeah.
I disabled it. Yes, it will create some impact.
Understood.
So, Ethernet requires timing, especially all real-time application. Voice is real-time. So Ethernet having 1588v2 synchronization protocol. This is all about of
backhauling.
So
there is a little bit of dead over which is happening. That's why.
No. I was silent.
Okay.
So till now we discussed that was on the data backhauling side or data side or OSS and MS application side. So now moving to the mobility architecture. So how much mobility architecture you are aware of, so that our discussions would be in that level only? 2G, 3G, 4G. What is your understanding?
No, I don't know anything. I mean, I am using it because with the speed and all, like how it actually got improved. I've seen from the generation wise. I don't know the in depth of it, but yes, I mean, I've seen from the day when actually we had that bigger phones in hand, where we used to get one call. I mean, that used to cost like 10 rupees, incoming 10 rupees, outgoing at that time. So that I have seen installed in my house. When for that installation, they used to take at least like 24 hours, because that used to be a big Ethernet line connectivity and all they used to do. Telephone connectivity. So that I have seen. So starting from that day till today, I have that understanding is like okay, when it moved from 1G to 2G, the speed got increased. We were able to see videos on phones, and based on that, we had the devices also. So how the devices actually got upgraded. So from the smartphone or smart devices, yeah, maybe I can talk a little bit. And yeah, a little bit is like when all these 2G, 3G were actually getting into the market, like what is the speed and capacity, as like how it will work and how it will not work on the remote area, how it is going to support on the urban areas, how it is going to support. So that little bit of understanding is there. Yeah. When we are traveling, like how it is going to affect. I mean, if you travel by train, I mean, I know it's in a layman term, but yes, when you try to connect via bus, so you have a little bit of signal is over there. When you connect via rail, you have a lot of disconnect happening. After 2G was never used to connect on rails. 3G had a little upgradation where it started showing a little bit of like at least a messaging which we used to receive. But later 4G came, and where we were able to do a little bit of calling over 4G on rails. Then air service, how it was. So I mean, as the product gets launched and a little bit of features what we actually try to get from the media and what we try to get from the online. So some of the areas, not the core area.
Okay, so no issue. Now we can check it out. GSM fundamental as a development wise, you can check it out. 1989 protocols developed, and first service in 1991 in European countries, and 1992. So mobile communication. So mobile global system for mobile communication, GSM network.
GSM network.
Global system for mobile communication.
Mobile communication. Yes.
Yes. So cell phone at that time it was only point to point kind of thing, but actual microcell technique like a coverage of geographical coverage that was starts from 1996. 1996. So here macrocell is basically at that time they developed this as a wireless because somewhere copper cable is not available in like distances 4 to 520 kilometers. So there they developed a high power transmitting BTS that giving the coverage of connectivity, wireless connectivity, where transport system is not available. So later on, coverage has been categorized based on different aspects like a frequency and all. Later on, we will discuss. So here, this converted as a microcell. It's low power BTS. Low power means more area to cover, less in distance, but area to cover. Coverage, not a longer distances. So earlier, it was designed for the longer distances. That time it was not like that I need to cover all geographical area.
Only limited it was.
Yes, since copper cable we can't lay out for that reason, like a LA region any. So in that case I can deploy this microcell and I can receive the calls. So they start sending signaling based on three things, that was FDMA, TDMA and CDMA. In a GSM system, out of these three adopted FDMA and TDMA, not the CDMA. Later on, did you remember Reliance Arcom launched CDMA?
WCDMA was there, right? CDMA, WCDMA.
Yes.
So that
GSM, correct. So GSM
SIMless without SIM.
No, SIMless is different concept. SIM is already there. You don't need to buy it. This is different story. FDMA and TDMA, frequency and time. Frequency and time, that is adopted by GSM. FDD, TDMA. So it is based on frequency in the air. So carrier, all the traffic and carrier will be carried out on the frequency. Same way, like one frequency at a one time, one subscriber. One TDMA, one time slot, in that particular time, one subscriber. Frequency. Look, one frequency, one subscriber is using. Another can't transmit over there because that is already in use. If we allocate the time slot, so another time slot, once it is free, I can send another subscriber on the same frequency because time slot is different timing. So I can send it. So combination of TDMA and FDMA, GSM starts combining this techniques to send the subscriber call or send the traffic via air as a carrier.
Understood.
TDMA, special coding mechanism. Nowadays, nobody is using. Arcom used only in India. Later on, it has been gone now. So only 2G is TDMA and FDM. These are nowadays India. Have you learned so much a spectrum word?
I keep hearing.
Yes, a spectrum is a hot word from last. A big scam. You also heard a spectrum. Yeah, so this
it's a scam.
yes. It's a government. Okay, this is another level. So you leave it. Major concern over here to understand the spectrum.
What is spectrum actually?
A spectrum is basically, just now we discussed the frequency, correct? So see, that means some defined value. So at that time, just now we studied one subscriber on a particular frequency at particular time, correct? So this statement using by Airtel, and at the same time, Tata also, TTSL also, or Idea also can use same frequency at the same time because it is in the air. Nobody can own the air. It is free for everybody.
Understood.
It is in the air. So what will happen? They will collide. Let us assume.
They will
collide.
They will collide. Okay. Your voice is actually cracking in between. Like one word I hear, there's another word I don't hear.
Okay. So let us assume there is air traffic controller, correct? Air controller, ATC tower and at airport. Every aeroplane is coming down and going up based on some coordinate as per the instruction by ATC.
ATC, yes.
Everyone has different coordinates. Correct. What will happen
That's right.
if we will not control, like a bird, any bird starts flying in the sky, but birds are not colliding? That means they are also keeping some check and balances.
Yes.
So that means at some value in the air, we should not choose the same frequency and same time for two different things, flying objects.
Correct.
The same funda over here. So that means government says, since it is free or anybody can use, so government says, I have some frequency range. That frequency range has been divided into 50. Now you start 50. Now you start to buy this so that no collision of voice will happen in the air, just like flying objects. Why?
Oh, okay. Okay.
So this is my air resource. This air resource is my spectrum.
Oh, okay. Okay.
For example, Wi-Fi is running on 2.4 gigahertz and 5 gigahertz. So anybody is open to use this Wi-Fi frequency? Anybody?
Okay.
No license required for 2.4 and 5 gigahertz for Wi-Fi.
Okay.
At our home, do I take any licenses for this? No.
No, I don't.
But at the same time, if any other Wi-Fi is nearby, then they may collide their signals.
Yes, there are chances. Yes.
So interference starts. Once interference starts, your traffic will be low, or maybe some error will generate in the air. Means while accessing via
possibility
yes, is
possibility.
There.
Yeah.
So that's why government says in the air there is nothing like invisible things. They are visible and they are controlled like a traffic on a road, highways.
But tell me why this thing has come now. When we have been using telecom from a very long time. Okay. What major difference did it get now? Because when you told me like, okay, I understand there could be a frequency or bandwidth or something. But like you said, why the spectrum thing has come now as a big in the market where people are talking about it so much. This is there from a very long time. Why there is a separate where government is asking us to go for this?
Okay. So first thing, understand technically. Technically, on a frequency side, you start moving in a air. If anything you plan into air, not a guided media. There's two things: guided media or unguided media. Correct? Guided means you are running on a wired media. This is called guided. Unwired means I can spread like anything. So light can spread, air can spread. So they are unguided media until unless fiber optics came into picture. If you are passing light into fiber optics, this is guided media. But you open a bulb, this is in an open area, this is unguided media. So once unguided media is there, and 30-40 years back, there is no too many wireless system. Very limited wireless system. Very limited. So this system has been invented especially not for the people. This has been invented for the defense, for fight, for war.
Oh, okay.
So first, every government has declared first control of any resources of any country holding by government. Let it be any natural resource. And after government, there is the command, military commands, defense commands, they are holding, they are using. So all this range has been allocated to the defense for their operation, where voice call exists. Look, all the frequency is not supported by voice. There is megahertz, in a kilohertz, hertz. So all are not supporting. You got my point? Technically, all frequencies are not supporting voice carriage. So a particular range where in the air voice is supported. That is FDMA. So in that range is held by defense as per the rule. This is India everywhere. Across the globe. If any war occurs, first ownership is lying with defense, although any private company buy from the country. So first ownership right is always for defense.
Line of contact is defense.
Yes. So what they did, once wireless system starts evolving, definitely they want some frequency range.
Yes.
And that frequency range is not free. So you need to take a permission from government to use. How government will give the permission, or if defense is using, because defense has highest priority. So that means defense says, for example, I don't remember the range, like is called GSM 900.
Okay.
So this is, for example, I am holding 2000 range, 0 to 2000 scale, correct? So 0 to 2000 range, I am ready to release 800 to 1000 frequency megahertz. From 800 to 1200, I am ready to release megahertz. Release means I stop all my services within this range and I am giving this range to the government. Government either sell it free or give it to on some leased license kind of license. What government will do, that is the government decision. But now onwards, I will not use my any communication, defense communication between 800 to 1000 megahertz frequency range, and this is handed over to government. That means if government is not use, defense will not use, means nobody is allowed even in a country to use within this. Till now it is clear?
Yeah.
Government decided, since collision will not happen, government decided I have 200 range, divide it into 800 to 850, 850 to 900, means as a layman right now using this word. 850 to another range 2, range 3 is 900 to 950, range 4 is 950 to 1000. Correct? 4 ranges we created.
Understood.
So I will start selling, okay, whosoever will, means I'm government, I can give it free, I have the rights, or as a good government, because I am giving it to the commercial company who will do the business, who will earn, so you give me the license cost. This is called a spectrum.
Okay.
And a scam is without any tender, because some of known to me, my friends, I give it to any other person free of cost.
Understood.
Free of cost means by another means.
So is this the reason why US has actually denied accepting 5G?
Not the reason. First, we are talking 2G only right now. So first understand a spectrum. Why a spectrum is charged as a license? Because everybody has a different frequencies. So that's why anybody sitting each other with other operator can talk to each other. No collision of network interference. So that's why it has been reserved. Whosoever will buy, they are allowed only to use that frequency. So that means very limited frequency.
Yes.
Quantify. You can quantify. So this has been saying uplink and downlink. Uplink and downlink.
Downlink.
Yeah. So if any tower is there from my mobile phone, if I'm sending something, this is my uplink. Coming back, this is my downlink. And uplink having frequency F1. Then downlink having a frequency F2. Not the same. You got it?
Yeah.
Link and downlink frequencies are different, not the same. Not the same. So that's why here it is written GSM 900 spectrum came into picture. They allocated 890 to 915 is how many? Total 25 megahertz. 25 megahertz separation is there. And 935 to 960, 25 megahertz separation is there. So we have the range of 25 megahertz. Megahertz. This is my uplink and this is my downlink. So now how we do the channeling? If you convert it into kilohertz, so this is 2500, 25,000, 1000 mega to kilo.
Kilohertz, mega to kilo, 1000. Yeah.
So this is now K. So divide by 200. How many channel we will get?
12,500.
No,
oh, sorry. 125.
So
200, right? Sorry.
125?
Yeah.
Separation as a guard band, 25, 45, because they should not collide with each other.
Yeah.
This is like a divider. On any national highway, there is divider in between the road. In between the road. So this is my divider on the highway. Going, this is my coming. So at a time 125 cell phone can be connected, 125 cell phone can be uplink and downlink connected. So 125 channels. So if I will activate my all channels, so maximum 125.
Yeah.
So these channels are getting sold as a spectrum. So somebody buy 12, somebody buy 15, some means 125 can't be allocated to one. This should be distributed to all the operators.
Understood.
The limitation is there.
Yeah.
So now check it out. So then limitation due to 125 only. Another spectrum came into picture. That is 1800 megahertz. So here you see this is 75 megahertz gap. Here it was
25 difference. Yeah.
25.
Yes.
If you convert it into kilohertz, 25,000
That's right.
and divide by 200.
375.
375. So earlier 125, now 375 channel.
Yeah.
Again, as a spectrum, it has been sold out.
Yes.
Correct?
Yeah.
So we have two spectrum range, 900 and 1800, and this type of this has been sold out. So generally you will buy the cell phone. It is written this phone is compatible 900 and 1800 spectrum. It is
Yes.
as a specification.
Mm-hmm.
Correct? And here
That's right.
separation is 95 megahertz divider for uplink and downlink. This is uplink and this is
Downlink.
So two spectrum we have till now for 2G. Frequency reuse, and just now we discussed entire range can't be allocated to one ISP. This is getting bid by the ISP. Government is allocating. Okay, you get 5 frequency, you get 10 frequencies like that. So that means if we allocate frequency, I will be exhausted within a 4-5 circle only. There was a concept of frequency reuse. Ultimately, in the air, if you use nearby the same frequency, there is the chances of collision. That is called interference.
Yes.
So frequency reuse concept came into picture. See this one. This is universal rule. 7 site, 1 cell reuse. 7 site hexagonal. Generally on the paper we are doing the planning in a hexagonal way. Hypothetical hexagonal we draw, like we cover one city and we drawing like that way, and we cover via one cell. How covering? See this one. This is one tower and cover with one tower, 3 direction.
Correct.
Assume this is F1. Now, the same direction I can't use F1. I have to. Here I can use F1. This is called frequency reuse because they are very far away. They are not reaching to each other. F1. So this is called frequency reuse. So that's why hardly 10 or 12 licenses they buy, and every telecom company buying like that way, or they are doing replanning like that way. The use of the frequency are covering entire country.
Understood.
So covering, here I was discussing covering. Covering could be, so for air coverage in air, we require antenna. So antenna could be of 2 types. Either one pole who will in a circle who will transmit, or there are three hardware means 3 pair. One is cover is 360-degree, that is called omni antenna, omnidirectional. Omni means everywhere in a circle, coverage in a circle. This is called sectorial antenna. Sectorial means particular in a degree, here to here. I will put up one device, they will cover only this direction. I will put up another sectorial antenna, this will cover here to here only. So 120-degree cell, omnidirectional cell, depends on the antenna. So if omnidirectional, only one device will be there, only one antenna. If 120, then total 3 antenna will be there for transmitting. So your cell phone is getting connected here in this cell.
Omnidirectional.
Yeah, if it is there, then this will connect here. If another cell, then they will connect the sector that is in front of this cell phone. This way. So ultimately passing all the traffic entering here, inside, here, inside. So 2 options are there. See, right now we are discussing only 2G. 2G means 2G network. That was for voice only. That voice network has been enabled to carry data as well. So GPRS has been invented protocol with voice that was able to carry the data. Data. So here in this case, in a mobile network, this is mobile station MS. This is MS. BTS tower is there, connected to BSC. So BSS and NSS. So BSS is holding BSC and BTS. They are able to handle voice call or internet data call. So if it is a voice call, they are passing it directly to the like this way. If it is a internet data, then they are passing through GPRS backbone. GPRS means data, internet. So from the cell phone, if I generate to call anybody, this will be passed like this way. And if I start browsing, then this will go like this way. Here GPRS. So this is for
GPRS.
This is for data.
Voice and data.
Yes. So this is called circuit switching. CS. Circuit switching. This is called packet switching. PS. CS and PS.
Yes.
Data is packet switching and voice is circuit switching. CS. So two major things. This portion is called RAN. You must heard the word RAN. Radio Access Network. Have you heard RAN?
Yeah.
The RAN portion. This is MSC portion. MSC. So basically, this is an exchange, brain of cell phone system.
MSC or RAN? Both.
Yes, MSC and RAN. This is MSC is generally kind of data center.
Oh.
Data center. This is yes spread geographically. This is centrally located. But yes, this is geographically spread. This is a brain. I connected with RAN. Different area I connected with RAN. Depends on geographical area.
Globally.
So here in this case, different protocols are there, like HLR, home location registry, subscriber data. You are filling the form for buying any SIM card, correct? So that SIM card, at the time of buying the SIM card, your data is getting fed in HLR here. SIM card is not here, your data is here. Filling the form, that data is filled up over here, and that is getting sent it to for this AUC authentication. Then forwarded to the, because everyone is connected via every section. So they are getting activation key and sending via to MS, filling the OTP or activation number in return. So activation is a two-way sync. Once it's done, then you start making the call. So call is happening that way. Then it is not going to HLR. But yes, at the time of call, your data is
passes HLR.
Yes, passing only, not the data. Call is not passing. Only the information.
Call is not passing. Information is passing.
Yes, this data is authenticated. Means this user is authenticated. Only user authentication is passing. Rest data is passing via another way. So generally, two signals generated from one cell phone. One is for customer, and another one for custom call management. So two are happening. So another is going this way, and customer call is going via this way.
The other way.
Yeah. Same way, packet, if internet packets are there, in this case, this red will happen again. But for the packet, on authentication
internet
in both cases. So you need to remember RAN. BSS and NSS is not the common global word. Actual common word is RAN and MSC. So now 5G, MSC is not a very big thing. RAN is very big thing because nowadays cloud RANs are also coming into picture. Cloud RAN.
Yes.
We will discuss. You heard cloud RAN?
No.
C-RAN.
These days, 5G. Yes. In that only I'm just when I watch such videos, I keep hearing such words. Yeah.
C-RAN, cloud RAN. No issue. So RAN is the common word. So you got it. What is RAN? RAN is the complete radio access network area. So these are the
random access network area.
No, radio.
Oh, sorry, radio. Oh.
Yes. So this is the same thing. These are the air interface. We don't need to remember if we are not going in a depth handling like a base, GB, GR. We need to remember because this, in mobility, whosoever handling CS or packet core or circuit core, they need to remember all this.
Okay.
But nowadays, these all are automated via OSS and NMS system. Like we discussed, everything is automated. Manually, you automated that. So system is same. Now moving towards after air interface. The SIM card, MS, mobile station, cell phone, that is called mobile station in 2G. So this mobile station containing two things, ME and SIM. ME, mobile entity, and SIM card. Mobile entity, ME means mobile equipment. Any cell phone having two things, SIM card and cell phone, active part, correct? Any mobile phone is having only two components. One is SIM and one is cell phone.
That's right.
So that's why it is written ME plus SIM, SIM. MS is equal to ME plus SIM. You got this slide?
Yeah.
So every mobile has IMEI number.
Yeah, that's right. Identity module.
Yeah, IMEI number is a unique number across the globe.
Yeah.
To identify the mobile.
Yes, yes.
So international mobile equipment identity, IMEI number, that is holding by mobile equipment, ME. International mobile subscriber identity, IMSI. SIM number, subscriber identity module, MC. SIM card number, because your phone having SIM card, your phone having SIM card. So that SIM card is called IMSI number. So SIM card number is basically a IMSI number. IMEI and IMSI. So MS is holding two numbers, IMEI and IMSI. So once you calling, remember this HLR, just now we discussed HLR. Yeah. This HLR is authenticating IMEI and IMSI number.
Okay.
In a mobile theft, HLR will find out IMSI is changed, but IMEI is the same. If we change the SIM card, that means IMSI number changed, but IMEI number is not changed.
Not changed.
So any theft case I report, so they mark it this IMEI number into HLR. This is the this is not a normal cell phone. This is theft case, and police will come to know. System will come to know. This is theft case cell phone. If I report it, got this point? So now subscriber identity module, SIM card. So what is inside the SIM card? What is inside the SIM card? So there are too many words. So I will request immediately, maybe not remember, but please understand the logic. So this logic is clear to you, then we can proceed. SIM card number, because everything is predefined. SIM number is also predefined. Only I do choose. So in MSI number, international mobile subscriber, temporary mobile subscriber identity, that is TIMC, location area identity, and subscriber authentication. Four things are there, four components, IMSI, TIMC, LAI, and KI. One is international number, one is temporary, and location area and authentication. You got this forward? International ID, temporary ID, location area, and subscriber. Authentication.
Authentication.
So here in this case, in a SIM card, we can check it out. Next, PSS. What is PSS? After your call is getting connected with these four factors, this 4 plus IMEI number is to the tower. This call is forwarded to the BSS system, means RAN area. Once your call enters into RAN machine, so BSS your call is getting processed. So in that processing BSS system, we have three layers: SM, BSC, and BTS. Base station controller having three things: transceiver, transcoder, and some multiplexer. See, what does it mean? Let me share here with you. If you initiate a call, GSM call, this call will first connect here.
Yeah.
At the same time, maybe another people try to call it.
That's right.
How this BSC will differentiate the call? First information it will receive, that is IMEI number or SIM card number, correct?
Yeah.
So they will get different IMEI, two different IMEI or two different SIM number. So system will come to know both are different cell phone.
Yes.
But how system will come to know this is authenticated or not authenticated? Whether I should further process this call or not. You got this line? So this BSC, this BSC have own mechanism, parameters, and this has three parameters. What are those parameters? So we will see here. We were discussing the parameters.
BSC.
Yes. So parameters is first parameter TC, MC, transcoder, and multiplexer, submultiplexer, transcoder or submultiplexer, BSC, base station controller, and base station receiver. Transceiver. Any signal will come. Since cell phone is transmitting towards tower, cell phone is transmitting, that means TX, transmitter to the tower. So this signal will received by receiver at the tower.
Yeah.
In return, I will transmit from tower. Cell phone will receive. So this is my RX, two-way communication.
Yeah.
So this is called TX and RX transreceiver. You got it? Transmitter, transreceiver.
Yeah. Yeah.
At the same time, another cell phone. So I receive two calls. So if I will carry these two calls, this is called multiplexing.
Multiplexing.
If I handle more than one channel at the same time on a different frequency, this is called multiplexing.
Yeah, that's right.
So here, base station controller, base station transreceiver, you got it?
Yes.
Transcode and multiplexing, you got it? So total three things: BTS, PSC, and transcoding. Now, once you pass it, then your call will be going towards either your packet core or your circuit core. Just now we discussed.
Yeah.
Do you remember here in this case?
Yeah.
It will go to either your circuit CS or will go to
Yeah.
Then you will call or you will browse the network, internet. So they are defining here packet controller unit, packet controller unit. So if this call is for data, they will process further like that. Else they will divert from here. Towards the internet. So we have transcoder, BSC and BTS. Only this has been added with BSC for PCU, packet control unit, or this PCU is connected with SGSN, signaling gateway network.
Okay.
What's GPRS? Means GPRS gateway. SGSN is GPRS gateway. GPRS is internet data. So added two things: PCU, packet core, and SGSN. Once you transferred packet, so definitely it will find out internet. So that's why internet gateway required. So we connected PCU and SGSN. Network switching system. So we are talking about the MSC. So once call processed into a data center, that change BSS, how call will be handled. Now we discuss once call arrived, so do we need to check the SIM number, user authentication, cell phone authentication? So authentication we required.
Yeah.
So here it starts working. HLR, VLR, EIR, so home location registry, visitor location, equipment, identity register, authentication center. So home or visitor means your data is uploaded, for example in Delhi, and I am moving to Chennai. So that will come to know I am visitor in this location. I am not the base, I am not the actual originator from this area.
Correct.
So this is called visitor location. So I am moving. So this nowadays no concept of roaming. Earlier visitor location means roaming.
Roaming, yes.
So now no charge, that is fine. But yes, my call is getting registered in a roaming call.
Let's say international right now.
Yes, same thing. Yes.
Yeah, understood.
So here in this case, they are doing this authentication, VLR or HLR. Then AUC authentication center, cancellation, equipment identity register. Equipment identity register means MC number, like this IMSI number, cell phone number is registered from any authorized manufacturer or some kind of thing. So generally equipment authentication also we do. SIM card authentication and equipment authentication, both we are doing.
Yeah. This I actually use it for mobile hacking.
Okay, this one?
Kind of. Mobile technique hacking.
So if I can manufacture any other cell phone and I can enter others IMEI number, technically I can do that in my factory. Is that possible?
Yes.
But since
it's possible.
All the global class A manufacturer, they don't do like that way. They have allocated some IMEI number, unique number. They are using that list from there only. Mobile switching center, what we do: call processing, operation and maintenance, interface management, inter-network and inter-working, and after call, the billing. It's happening like in a data, we discuss in a data, like OSS, NMS, we do serving and all. So all this we can maintain. Same thing in a voice call. Okay, HLR. How HLR do the authentication? MSI number means SIM card. SIM card,
Mhm.
VLR, rental location, supplementary information, and subscriber status, registered or deregistered. Authentication key and authentication and AUC functionality, authentication code. So all this we can check it out in HLR. I'm not in a deep detail because we don't require right now.
Yeah,
Unless we are working on HLR or we are HLR expert. In a VLR, what we're doing? We are checking mobile status. MC attached means my SIM card. Location area identity. Location area means particular which area I am moving, especially moving and my area registered my cell phone. So location area. Temporary fiber. TMC. Temporary. Look, some SIM card number is already generated. That is for the public. We are using for public display. But internal call once connected, there is another temporary number is generated. That is that visibility or live till the call is live. Once call is disconnected, that number is also finished.
Finished. Yeah. That's a temporary number. Yeah.
Yes, temporary. But this is not visible to this visibility to the system only, not the outside.
System only. Yes.
Allocating the roaming number. Yes, inside roaming number also allocating, but that is also not for the public. This is internal. Means if you are in VLR, some another number is getting activated inside for handling, but for the public, the SIM card you are MC number, this is the number for the public. But inside for every activity, every roaming, your TMC or VLR number in roaming number, all will be changed. Once call is finished, you come back from roaming, all are now MC is the permanent address.
Understood.
So we can have this equipment. So right, for today, any query or any question you can please ask, or we can repeat.
No. As of now, nothing. Thank you.
Thank you, Deepak.
Thanks for watching. Don't forget to subscribe to our channel.